prohibitive.
Mm-hmm.
Inference of better models will indeed become more expensive. But is it prohibitive? Well, it depends on how useful is it. Like if it is more useful than it is expensive, then it is not prohibitive. Like to give you an analogy, like suppose you want to talk to a lawyer, you have some case or need some advice or something. You are perfectly happy to spend $500 an hour, right? So if your neural net could give you like really reliable legal advice, you'd say, I'm happy to spend $400 for that advice. And suddenly inference becomes very much non-prohibitive.
Mm-hmm.
The question is can neural net produce an answer good enough at this cost?
Yes, and you will just have like price discrimination, different models at different levels.
I mean, it's already the case today. So on our product, the API, we serve multiple neural nets of different sizes, and different customers use different neural nets of different sizes depending on their use case. Like if someone can take a small model and fine tune it and get something that's satisfactory for them, they'll use that.
Yeah.
But if someone wants to do something more complicated and more interesting, they'll use the biggest model.
How do you prevent these models from just becoming commodities, where these different companies just they just bid each other's prices down until it's basically the cost of the GPU run?
Yeah, I think there is without question a force that's trying to create that, and the answer is you got to keep on making progress. You got to keep improving the models. You got to keep on coming up with new ideas and making our models better and more reliable, more trustworthy, so you can trust their answers. All those things.
Yeah, but let's say it's like 2025. And the model from 2024, somebody just offering it at cost, and it's like still pretty good. Why would people use a new one from 2025 if the one from just a year older is, cheap and better?
So there are several answers there. For some use cases, that may be true. There will be a new model from 2025, which will be driving the more interesting use cases. There's also going to be a question of inference cost. Like you can do research to serve the same model at less cost. So there will be the same model will cost different amounts to serve for different companies. I can also imagine some degree of specialization too, where some companies may try to specialize in some area and be stronger in a narrower area compared to other companies. And I think that too may be a response to commoditization to some degree.
As over time, do these different companies, do their research directions converge or they diverge? Are they doing similar things over time, or are they branching off into different areas?
So I'd say in the near term, it looks like there is convergence. I expect there's going to be a convergence, a divergence convergence behavior, where there is a lot of convergence on the near term work. There's going to be some divergence on the longer term work. But then once the longer term work starts to yield fruit, I think there will be convergence again.
Got it. When one of them finds the most promising area, everybody just...
That's right. Now, there is obviously less publishing now, so it will take longer before this promising direction gets rediscovered.
Mm-hmm.
But that's how I'd imagine it. I think it's going to be convergence, divergence, convergence.
Yeah. We talked about this a little bit at the beginning, but as foreign governments learn about how capable these models are, are you worried about spies or some sort of attack to get your weights or, somehow abuse these models and learn about them?
Yeah, it's definitely something that you absolutely can't discount that.
Yeah.
And yeah, something that we try to guard against the best of our ability, but it's going to be a problem for everyone who's building this.
How do you prevent your weights from leaking?
I mean, you have like really good security people.
And how many people have if they wanted to just SSH into the weights, how many people could do that?
I mean, what I can say is that the security people that we have, they've done a really good job, so that I'm really not worried about the weights being leaked.
Okay, got it. What kinds of emergent properties are you expecting from these models at this scale? Is there something that just comes about de novo?
I'm sure things will come. I'm sure really new surprising properties will come up. I would not be surprised. The thing which I'm really excited about, or the thing which I'd like to see, is reliability and controllability. I think that this will be a very important class of emergent properties. If you have reliability and controllability, I think that helps you solve a lot of problems. Reliability means you can trust the model's output. Controllability means you can control it. And we'll see. But it will be very cool if those emergent properties did exist.
Is there some way you can predict it in advance? What will happen in this parameter count? What will happen in that parameter count?
I think it's possible to make some predictions about specific capabilities, though it's definitely not simple and you can't do it in a super fine-grained way, at least today. But I think getting better at that is really important. And anyone who is interested in, who has research ideas on how to do that, I think that can be a valuable contribution.
How seriously do you take these scaling laws? If like there's a paper that says like, oh, you just increase, you need this many orders of magnitude more to get all the reasoning out. Like, do you take that seriously, or do you think it breaks down at some point?
Well, the thing is that the scaling law tells you what happens to your next word prediction accuracy, right? There is a whole separate challenge of linking next word prediction accuracy to reasoning capability. I do believe that indeed there is a link, but this link is complicated. And we may find that there are other things that can give us more reasoning per unit effort. Like, for example, some special, like, you mentioned reasoning tokens, and I think they can be helpful. There can be probably some things that
Is something you're considering just hiring humans to generate tokens for you, or is it all going to come from stuff that already exists out there?
I mean, I think that relying on people to teach our models to do things, especially, to make sure that they are well behaved and they don't produce false things, I think is an extremely sensible thing to do. And
Isn't it odd that we have the data we need at exactly the same time as we have the transformer at the exact same time that we have these GPUs? Like, is it odd to you that all these things happen at the same time, or do you not see it that way?
I mean, it is definitely it is an interesting situation that is the case. I will say that it is odd and it is less odd on some level. Here is why it's less odd. So what is the driving force behind the fact that the data exists, that the GPUs exist, that the transformer exists? So the data exists because computers became better and cheaper. We've got smaller and smaller transistors. And suddenly at some point it became economical for every person to have a personal computer. Once everyone has a personal computer, you really want to connect them with the network. You get the internet. Once you have the internet, you have suddenly data appearing in great quantities. The GPUs were improving concurrently because you have smaller and smaller transistors and you're looking for things to do with them. Gaming turned out to be a thing that you could do. And then at some point, the gaming GPU, NVIDIA said, wait a sec, Ryan, may turn it into a general purpose GPU computer. Maybe someone will find it useful. Turns out it's good for neural nets. So it could have been the case that maybe the GPU would have arrived 5 years later or 10 years later. Let's suppose gaming wasn't a thing. It's kind of hard to imagine. What does it mean if gaming isn't a thing? But maybe there was a counterfactual world where GPUs arrived 5 years after the data or 5 years before the data. In which case, maybe things would move a little bit more. Things would have been as ready to go as they are now. But that's the picture which I imagine. All this progress in all these dimensions is very intertwined. It's not a coincidence that, like, you don't get to pick and choose in which dimensions things improve, if you see what I mean.
How inevitable is this kind of progress? So if, like, let's say you and Jeffrey Hinton and a few other pioneers, if they were never born, does the deep learning revolution happen around the same time? How much does it delay it?
I think maybe there would have been some delay, maybe like a year delay. It's really hard
Really?
to tell.
That's it?
It's really hard to tell. I mean, I hesitate to give a longer answer because, okay, well, then you'd have GPUs would keep on improving, right? Then at some point, I cannot see how someone would not have discovered it. Because here's the other thing. Okay, so let's suppose no one has done it. Computers keep getting faster and better. It becomes easier and easier to train these neural nets because you have bigger GPUs. So it takes less engineering effort to train one. You don't need to optimize your code as much. When the ImageNet dataset came out, it was huge and it was very, very difficult to use. Now imagine you wait for a few years and it becomes very easy to download and people can just tinker. So I would imagine that, like, a modest number of years maximum. This would be my guess. I hesitate to give a longer answer, though. You can't rerun the world. You don't know.
Let's go back to alignment for a second. As somebody who deeply understands these models, what is your intuition of how hard alignment will be?
Like, I think so here's what I would say. I think with the current level of capabilities, I think we have a pretty good set of ideas of how to align them. But I would not underestimate the difficulty of alignment of models that are actually smarter than us, of models that are capable of misrepresenting their intentions. Like, I think it's something to think about a lot and to research. I think this is one area also, by the way, Like oftentimes academic researchers ask me what's the best place where they can contribute. And I think alignment research is one place where I think academic researchers can make very meaningful contributions.
Other than that, do you think academia will come up with important insights about actual capabilities, or is that going to be just the companies at this point?
So the companies will realize the capabilities. I think it's very possible for academic research to come up with those insights. I think it doesn't seem to happen that much for some reason, but I don't think there's anything fundamental about academia. Like it's not like academia can't. I think maybe they're just not thinking about the right problems or something because maybe it's just easier to see what needs to be done inside these companies.
Mm, I see. But there's a possibility that somebody could just realize,
Yeah, I totally think so. Like why would I possibly rule this out?
yeah,
You see
yeah,
what I mean?
yeah. What are the concrete steps by which these language models start actually impacting the world of atoms and not just the world of bits?
Well, you see, I don't think that there is a clean distinction between the world of bits and the world of atoms. Suppose the neural net tells you that, hey, like here is like something that you should do and it's going to improve your life, but you need to like rearrange your apartment in a certain way. And you go and you rearrange your apartment as a result. Did the neural net impact the world of atoms? Just
Yeah, fair enough. Fair enough. Do you think it'll take a couple of additional breakthroughs as important as the transformer to get to superhuman AI? Or do you think we basically got the insights in the books somewhere and we just need to implement them and connect them?
so I don't really see such a big distinction between those two cases, and let me explain why. Like I think what one of the ways in which progress has taken place in the past is that we've understood that something had a property, a desirable property all along, which we didn't realize. So is that a breakthrough? You can say, yes, it is. Is that an implementation of something on the books? Also, yes. So my feeling is that a few of those are quite likely to happen, but that in hindsight, it will not feel like a breakthrough. Everybody's going to say, oh, well, of course, like it's totally obvious that such and such thing can work. You see, with the transformer, the reason it's being brought up as a specific advance is because it's the kind of thing that was not obvious for almost anyone. So people can say, yeah, like it's not something which they knew about. But if an advance comes from something, like let's consider that the most fundamental advance of deep learning, that a big neural network trained with backpropagation can do a lot of things. Like, where's the novelty? It's not in the neural network. It's not in the backpropagation. But then somehow it's the kind of, but it is most definitely a giant conceptual breakthrough because for the longest time, people just didn't see that. But then now that everyone sees it, everyone's going to say, well, of course, like it's totally obvious. Big neural network. Everyone knows that they can do it.
What is your opinion of your former advisor's new forward algorithm?
I think that it's an attempt to train a neural network without backpropagation. And I think that this is especially interesting if you are motivated to try to understand how the brain might be learning its connections. The reason for that is that, as far as I know, neuroscientists are really convinced that the brain cannot implement backpropagation because the signals in the synapses only move in one direction. And so if you have a neuroscience motivation and you want to say, okay, how can I come up with something that tries to approximate the good properties of backpropagation without doing backpropagation? That's what the forward algorithm is trying to do. But if you are trying to just engineer a good system, there is no reason to not use backpropagation. Like it's the only algorithm really.
Mm. I guess I've heard you in different contexts talk about the need, like using humans as the existing example case that, AGI exists, right? So at what point do you take the metaphor less seriously and don't feel the need to pursue it in terms of the research? Because it is important to you as a sort of existence case.
Like at what point do I stop caring about humans as an existence case of intelligence?
Or as the sort of, as an example of the model you want to follow in terms of pursuing intelligence in models.
I see. I mean, like I think it's good to be inspired by humans. I think it's good to be inspired by the brain. I think there is an art into being inspired by humans and the brain correctly because it's very easy to latch on to a non-essential quality of humans or of the brain. And I think many people whose research is trying to be inspired by humans and by the brain often gets a little bit specific. People get a little bit too, okay, so like what cognitive science model should we follow? At the same time, consider the idea of the neural network itself, the idea of the artificial neuron. This too is inspired by the brain, but it turned out to be extremely fruitful. So how do you do this? What behaviors of human beings are essential that you say, like, this is something that proves to us that it's possible? What is inessential? No, actually, this is like some emergent phenomena of something more basic, and we just need to focus on getting our own basics right. I would say that it's like, I think one can and should be inspired by human intelligence with care.
Final question. Why is there, in your case, such a strong correlation between being first to the deep learning revolution and still being one of the top researchers? You would think that these two things wouldn't be that correlated, but why is that correlation?
I don't think those things are super correlated indeed. I feel like in my case, I mean, honestly, it's hard to answer the question. I just I kept trying really hard, and it turned out to have sufficed thus far.
Got it. So it's a perseverance.
I think it's a necessary but not a sufficient condition. Like, many things need to come together in order to really figure something out.
Mm-hmm.
Like, you need to really go for it, and also need to have the right way of looking at things. And so it's hard to give him like a really meaningful answer to this question.
Got it. Ilya, it has been a true pleasure. Thank you so much for coming on the Lunar Society. I appreciate you bringing us to the offices. So thank you.
Yeah, I really enjoyed it. Thank you very much.